Hello students, welcome to the next lecture on the CSR UGC NET. Today we will discuss about the real analysis questions from the paper June 2017. We will cover all those part B as well as part C questions with the help of shortcut tricks. Myself Dr. Harish Garg. You can simply follow my YouTube channel. The name is Dr. Harish Garg. Otherwise you can simply join my WhatsApp group through this barcode. What you will be found on my YouTube channel, there is a playlist of the CSR UGC NET where you can find the PY questions related to the last 12 years of partial differential equation, real analysis, ordinary differential equation, Markov chain, calculus of variation, linear algebra, almost each subject which was asked in the CSR UGC NET. You can simply follow this CSR playlist. So let's start with this question. So as I discuss in my all videos, I will always give you the tips, shortcut tips for solving each question. Remember that whenever there is a question of 1 minus 1 raised to power n, whenever, and they are asking you find the limit supremum and infimum, you always break this limit into the two portion. One is when n is even, second is when n is odd. Always remember. Then you can find the solution within a 15-second answer. What will happen if you substitute n is even, so it is a plus 1, so your simplified expression will be here, and this will be my this. Now if you take the limit n approaches infinity, what will happen? This part is nothing but e, next part is nothing but my e raised to power minus 1. So what is that? We all know e is my 2.71, 1 by e is 1 over 2.71, that's a 0 point something. So this part will be my supremum, this part will be my infimum. So supremum is e, infimum is 1 by e is the right answer. Another tips for you for the particular this kind of the question. So if what will happen if you are unable to remember the limits, then what is the shortcut tips for you? Again, how you can find the limit? Remember, whenever the limit is of this form, say x, fx and gx, if you substitute the value as x approaches infinity, if it's of this form 1 raised to power infinity, then whenever this is of this form, then the shortcut tips for you, you can find the limit as directly limit x approaches infinity fx gx. That's a simple tips for you. For example, here if you take n approaches infinity, it is 1 plus 0 is 1, so it is a 1 raised to power infinity form. So what is the answer is e raised to power limit fx is my 1 by n, g is my here, so what is that? This is e raised to power 1 is e is the right answer. Same for here, it is 1 raised to power infinity, so the answer will be e raised to power limit g, f is my minus 1 by n, because you have to compare with the plus sign, and g will be here, so this is e raised to power minus 1. If I write you one more example, like say what is the limit of 1 by n square of n, limit n approaches infinity. This is not an e, but you can see it is 1 plus infinity, 1 plus 0, 1 raised to power infinity. So what is the limit is e raised to power, f is my 1 by n square of n. So as n approaches infinity, it's a 1 over infinity 0, e raised to power 0 is 1 is the right answer. Say one more example related to this concept. If I ask you find the limit as n approaches infinity of 1 plus 1 by n cube of n square. Again you can see 1, or you can say 7, for example 7. So again you can see 1 plus 0 is a 1 raised to power infinity. So the answer is e raised to power fx 7 over n cube into n square. So what is the limit as n approaches infinity? 1 by n, 7 by n, 7 by n is goes to the 0, answer is my 1. So remember, this is the tips for you, you can easily remember in the future exam. Okay, now look at that, you have to find the limit of this. Here, limit 1 over n factorial raised to power 1 by n as n approaches infinity. So the major question arises here is how you can find this. So if I consider this is my an, only this portion, fine. How you can find the limit of this? Clearly says if you think about that, I can try to solve like this manner, then it will be very complicated because of this 1 by n. Then how you can solve that? So it is not an easy target. But whenever such kind of the question given to you in the examination where you are unable to solve the limit with the help of, what is that, with the help of simple the tips or the tricks or the concept which you studied in your master class, then what you can do, you can find the value of a1, a2, a3 and try to analyze that trend. What is the a1? 1. a2 2 factorial of this, a3 3 factorial 6 raised to power 1 by 3, 4 factorial 24 1 by 4 and so on. So it is my 1. 2 raised to power 1, so it lies between the 1 and 2. 6 raised to power, so 1 cube is my 1, 2 cube is my 8, so 6 lies between them, so it is lies between 1 and 2. 24 raised to power 1, so it's a 1, 2 raised to power 4 is 16, 3 raised to power 4 is my 81, so 27 lies in between them, so it is my 2 and 3. If I found the value of the a5 is my 120 raised to power 1 by 5. Again we all know 2 raised to power 5 is 32, 3 raised to power 5 is 343, so it is lies between 2 and 3 and so on. So clearly say that the first value will be 1, this pair will be lies between 1 and 2, this is lies between 2 and 3 and so on. So it clearly says whenever you take and say 100, so it will be 100 factorial of 1 by 100 which is greater than of the 2 comma 3. So it means when you take as n approaches infinity, this an will goes to the infinity limits. So this will goes to the infinity. So what is the limit of this? Will goes to the 0. So this trick will help you when you are unable to find the limits in any manner. Then you can try to find the sequence and analyze their behavior. Okay, next one is the series is given to you ln of n here. Then you have to find the condition for the convergent. So how you can check for the convergent? Either you can start from the an plus 1, you can check whether it's a less than 1, you can apply the ratio test and then so on, or root test. But I will tell you the simple shortcut tips for you. Whenever there is an option is given to you, what you will do, you will check about the options. Here you can see there is a equality given. So firstly we will check about a is equal to e, because equality given. So what is that? This is e raised to power ln of n. What is that? This is n. So what is my series? Series will be n, and we know this is my divergent series. How? You can see it's a or you can either you also write this as 1 over this. So by the p test it is also be a divergent. So once it's a divergent, it means this series is this option is cancelled out. Fine. So it means this a is less than equal to e will be cancelled out. Now look about this option. A lies between open interval of this. Now we all know e is my 2.718. So if a belongs to my open interval of this, so what is the meaning of that? If a will approach towards 718, like if I say my this value here, this is open, it lies in the open interval. So what is my limit of this? It is again approaches toward the infinity, because again this limit will approximately be the n. If this is approximately be n, then again it goes to the infinity. So it means it is not a convergent. Look at the third option. Again now there is equality in the third option here. So we can check about this case. A is equal to 1 by e. So the series will be 1 over e raised to power ln of here. So I can return this number as 1 over e raised to power, sorry, this is only ln. So this is e raised to power ln of this. This is 1 by n. Again you can see this is my divergent, and their limit will goes to the 0. So this is a divergent, this option is cancelled out. So the only right option is my here. How? You can see this is the open interval of 0 comma 1 by e, and this limit will goes to the 0, but it is this series is divergent, limit is goes to 0. So when you take any of the number which is open interval of this open, so this limit will goes to the 0, and we all knows when the series will be convergent, if its nth term will goes to the 0. So this is the right answer of the problem. Okay, look at this function. Function is given to you as sin x over x and 1 when 0 and the non-zero. Then you have to discuss about its continuous, differentiability, bounded. How you can check about the continuity? You can check the limit 0 minus is a 1. What is the limit of the 0 positive? It is also 1. What is the limit at point 0? It is also 1. So what is the meaning of that? Function is continuous. So the first option is the function is not continuous, cancel out. Once the function is continuous, what is the meaning of that? Function is bounded as well. Every continuous function is a bounded. So the right option, fourth option is also cancelled out. Now you check whether it's a differentiable or not. So what is the f dash? X square, x cos x minus sin x. Fine. Now you can check the limit as x approaches 0 of f dash, 0 minus 0 positive. And firstly, this is when x is equal to 0, the limit will be, differentiation will be 0. When x is non-zero, the limit will be, if I say this is my g, then it is my g here. So what is the limit of this? So it's a 0 by 0 form. So again we will apply the L'Hopital rule. So if I derivative them, it is my cos x minus x sin x minus of cos x. So it will be 0. So once x will be, sorry, it is x square. It is my here. So it is cancel out. So when you take 0, it is my 0. Sin 0 will be 0. So 0 by x. This is the right answer. Now, that is my mistake, because f of 0 is not be 0. So you can't say like of this manner. So how you can take this is f of x minus f0 over x. So f of x is my sin x. So this is my sin x over x. F of 1 is 1. So I can take the LCM as here. Now you can take the limit. It's again 0 by 0 form. Now you can take them. It's a cos x minus 1 over 2x. Again it's a 0 by 0 form. So it is my minus sin x over 2. So the limit will be 0. Fine. And it is also there. So f dash exists. F dash exists. Now once f dash exists, can you say it's a differentiable function? Now you can check about here. You can see what is the f dash for all x. So it is a sin x. Sorry, it is my, if you take the derivative of this, it is my cos x over x minus sin x over x square. Now what is the limit as x approaches 0? This value will go to the infinity. This is, I can written as x into x. This part will be 1. So this is infinity minus infinity. It means f dash does not exist. So it means, f dash is not differentiable. So once it's not a differentiable, so third option cancel. Second option is the right answer of the problem. Look at this next question. This is my x. This is my x. So uniform continuous. Remember, whenever you are talking about the uniform continuous, you need to check firstly whether it's a piecewise continuous or not. If it is a piecewise continuous, then there may or may not be a uniform continuous. Remember, uniform continuous implies piecewise continuous, but not piecewise continuous implies not uniform continuous. So you can see it's a not piece continuous. So we will check whether it's a piecewise continuous or not. We will check the limit as n approaches infinity of fn. What is the fn is? X e raised to power minus of nx square. So what is the limit of this? This is 0. So which is exist. So it means yes, it is a piecewise continuous. Fine. So but we can never say it's not a uniform continuous. So this option is may or may not true. So how you can apply the uniform continuous? We always apply the Mn test. What is the Mn test is? You can take the supremum fnx minus fx. What is the domain is? Domain is real line. If you prove that it will goes to the 0, then it's a uniform continuous, otherwise not. Remember, goes to the 0. Now what is the supremum? X, what is the fnx is x e raised to power minus nx square. Fx is by 0, so it is here. How you can find the supremum over the real line? Minus. So if I consider this function as say my y, so y is my, what is the condition for the supremum? That is a maxima. So that will, you can take the first derivative as a 0. So the first derivative will be my here minus 2nx with respect to x plus e raised to power minus nx square is 0. So what is that? E raised to power minus x square will be cancelled out. Minus 2nx square plus 1 is 0. X will be 1 by root 2n. So if I substitute here, it is 1 by root 2n e raised to power minus, this is 1 by 2. So now supremum, it's a n. So take as n approaches infinity, check whether it goes to the 0 or not. So as n approaches infinity, it goes to the 0. So it means yes, it is a uniform continuous. So this uniform convergent, so it's cancel out. It's a right answer. So it's a converges to 0 for all x belongs to the R. So it means it said only on the compact side, it's a cancel out. How you can check this unbounded function? So we all know if the function is uniform convergent, it means it is my bounded always. So it is unbounded, it's a cancel out. Right answer is my A on. Okay, look at this one. You have to find the radius of convergence. So what is the simple tricks for you? You have to find the limit supremum of an 1 by n, or you can take limit an plus 1 over an. Remember, this formula will be applicable only when you have the an in terms of power n, like of 2 raised to power n x raised to power 2n. So this is in terms of the power n. Then you can find its limit as of here. So here an is my log of n. What is the an plus 1 over an? Log of n plus 1 over log of n. Now if you take the limit as n approaches infinity, it's an infinity by infinity form. So you can take the derivative and it goes to the 1. So the right answer is, this value will be my 1. So the answer is 1 over 1 is my right answer of this problem. Okay, look at this one. Let A is the set of all those natural number such that n is my either 1 or n is a factor of 2 and 3. Like 6 is a factor of the 2 and 3. 10 is a factor of the 2 and 5, but we need only 2 and 3. So this does not belong to the A. I can say 12. 2 square of 3. So this is the factor of here. So what is the journal form of the n? So it is 2 raised to power p, 2 raised to power q. Because if my say p and q are my 0, so it is my 1 satisfied. And if p and q are non-zero, then it is of the any form. So what is that? So what is the minimum value of the p and q? 0. Highest value will be from the natural number. So A is a finite, cancel. S is my here. Summation n belongs to the A 1 over n. I can substitute this value of the n here. What is the limit? This is the p. One is p0, second from the q0 to the infinite. 1 over 2 raised to power p, 2 raised to power q. So what is that? I can simply write, because they are the independent natures, so I can write this part as a separate, and this limit for the q 0 to here. So what is the answer of this? The first term is my GP. These are my GP series. So the ratio is 1 over here, and this is 1 over, this is of this. So what is the answer of the first part? Is a 2. Second part is my 3 over 2. So the right answer is my 3 is the right answer. And since the limit is, this is the GP series. GP series is a convergent series when the ratio is less than 1. So you can see the series are ratio is less than 1. So it's a convergent series. This is the GP series. Ratio is my 1 by 2 and 1 by 3. So sorry, it's a 1 by 3. 2 raised to power p, 3 raised to power q. Okay, look at this next one. Alpha is given to you in this form, 1 1 1 1 1 1 and so on and so on. and which of the following is the rational, irrational, and so on. So you can see this is a non-terminating series. Fine. If alpha is a rational number, what is that? P over Q, like 1 over 5, I can say it's a 0.2. 1 over 3, I can say 0.3333 and so on. Whenever alpha is a rational number, it always has a periodic decimal expansion. Fine. What is the meaning of the periodic is? Like here, after the certain decimal it repeats, but here you can see it is non-repeated. Firstly 1 0, then 1 1 0 1 1. So it is a non-repeating. It is a no periodic decimal expansion. What is the meaning of that? Alpha is not rational. It means it is my irrational. Not rational doesn't mean that it is a irrational, but once it's a non-periodic, it implies it's a irrational. So the second option is correct, first option cancel, fourth option is correct. Now check about the third option. For every Q which is greater than or equal to 2, there exists an R which is greater than or equal to 1. So since it exists for all, I can simply take Q is my 2, R is my 1, because equality here. Now based on this, what is the R over Q? Here, alpha 2 over 2. Fine. R plus 1 is 2 over 2. So can the alpha, this alpha lies in between them? No, because this is 0.5, this is 1, but alpha is my 0.1, it does not belong to them. So this option is cancelled. Right answers are B and D are the correct answers. Okay, A and B are my natural numbers such that this sequence, which of the following statements are true? What is the value of the A and B? Is it given to you? No. So you can choose any value as per your convenience. If I take A is by 1, B is my 2. Fine. That is, I consider the first case here. What is my D of N? That is NC1, NC2. What is the NC1 is N, NC2 is N minus 1 of 2. What is that? If you take N approaches infinity, this will goes to the 2. So remember, the sequence AN is convergent when you take limit as N approaches infinity, if it is a finite. Whatever, whether it's a 1, 2, minus 1, 2, whatever is there, if it is a finite, then it is a convergent. So now you can see here, this is my finite. So whenever B is my greater than of the A, it is my convergent. What will happen if you take A is equal to B? If I simply take A, B both are 1, what is my here? NC1, NC1, that is a 1, which again is my finite as N approaches infinity. So it means this is also be a convergent. If I take the second, A is greater than B. If I take A is my 2, B is my 1. What is my here? NC2, NC1. N minus 1 over 2, NC1 is my here. So what is that? This will goes to the infinity, which is not finite. So it is not finite, it means this is my divergent. It cancels. So since it does not convergent for A greater than B, so it does not converge for all. It only converges when these two conditions satisfy. B and C are the correct options. Okay, look at this next question. Which of the following AN is a sequence such that this condition satisfied? This is my finite. Then you have to check about the nature of this. That's a very simple. If you read this statement carefully, can you imagine any of the sequence which goes to the 0? Less than infinity means that's a finite. If I simply take 1 by n, what will happen? You can see 1 by n, n minus 1. What is that? This is 1 over n, n minus 1, which goes to the 0 as n approaches infinity. That is a finite. So it means, what is my series for A? An is my 1 by n of this. Now you can check about that. It converges nowhere, it converges everywhere, and so on. When it will be converges, if I simply take x is 1, the series will be, is it convergent? It is divergent always by the p-test, by p-test. So it converges everywhere. It's a cancel out on the real line, nowhere convergent. If I simply take x is -1, which belongs to the real line, okay, then what will be the series? -1 raised to power n over n. It is my convergence by Leibniz test. So it means nowhere convergent, cancel out. So first and second option cancel out. So what is the meaning of that? It convergent on -1 but divergent on the +1. So that is the series of the convergent. So it converges only on the open interval, but it's a wrong, because on the -1 it's a convergent. It's a cancel out. On some set containing of this is the right answer, because it converges in between them as well and here. This option is cancelled because of the word only. Remember, because -1 is also containing them. Okay, look at this next question. Fx is given to you as tan inverse x. You have to check firstly, there exists a polynomial. What is the degree of the polynomial? Is it given to you that is a even or odd or the constant? No. So you just check that whether there exists any polynomial which satisfied here. I think that's a very simple. If you take the derivative, it is 1 plus x square. So if I simply take my polynomial is 1 plus x square, so it's satisfied. That's a right answer. Now look at that second nth derivative. N is even. So if I take the second derivative, minus 2x 1 plus x square, and you can see second derivative at the point 0 is 0. It exists for all. Okay, we can check one more. What is the third derivative? If I simply take 1 plus x square power 4, 1 plus x square of square minus of 2, and minus of 2 into 2 times 1 plus x square of 2x. Fine. And if you take the fourth derivative, or I can simply take the third derivative in another manner, I can simply take 2 over 1 plus x square plus minus 2x 1 plus x square is to power 2, and it is first I can take x, this u into v, this second is here, it's a minus 2 over cube and minus of 2x. This is the derivative. Now if I take the fourth derivative, what is that? This is my minus 4 2x over power 4, and it's a 1x still be there, so it is in terms of the x are there. So clearly says that second derivative 0. If you take fourth derivative at the point 0, what will happen? This part will 0, this part will be 0. So it exists for all the even numbers. That's the correct state. F of n is 0 for all n. What is that? What is the first derivative as a 0? 1, which is non-zero. So first one is non-zero. Similarly, you can see the third part. What will happen if x is 0? If I take about here, this part will be 0, this part will be my minus 2. So what is the meaning of that? The nth derivative will be 0 when n is even, non-zero it is odd. And what is the value of the odd is 1, minus 2, and some are here, so it is unbounded. Sorry, it is unbounded. It's a correct statement because it is unbounded. So the right answers are my A, B and C are my correct answer of the problem. Fine. So then look at the next question. F of n is given to you as 1 plus n square x square. Again, it's a convergent pointwise uniformly and so on. So we will firstly find the limit as n approaches infinity. This goes to the 0. So what is the meaning of that? It's a pointwise, converges pointwise. How you can find this uniform convergent? We will take the limit supremum fn minus fx. Fx is 0, supremum 1 over 1 plus n square x square. So if I take y is this case, if I take the first derivative minus 2n, here is 0. So it means either x is 0 or derivative is undefined at the point x is 1 by ignoring the plus minus sign. Or you all knows what is the meaning of the supremum. Supremum is you have to take the maximum. It means you need to take this as a minimum. So when it will be minimum, you can simply take the derivative ignoring the plus minus sign. So what is that? This is on the real line. If you take x is plus minus, it is 1 plus 1. Supremum x belongs to the real 1 by 2, which is not 0. It means it is not uniform continuous. So the fourth, this converges, cancel out. It's a pointwise convergence, yes, and converges to the continuous function 0. 0 is a constant function. Every constant function is my continuous function, is the right answer. Now you have to check the fourth option. Limit 0 to 1 of fn. Here, what is the limit integration of this? This is my tan inverse nx over n. So what is the limit when x is tan inverse n over n? When it's a 0, it's a 0. Now take n approaches infinity. It's infinity by infinity. So it's a 1 by n square over 1. What is that? If it is infinity, it goes to the 0. Look at the right hand side. This value is nothing but my fx. Fx is my 0. So integration of this is a 0. Both are same, is the right answer. So A and D are the correct options. Okay, look at this one. Lambda exists, bounded, unbounded, and here. So firstly, we will simplify that. What is that? This is 1 plus t raised to power minus 1 over here from 0 to 1. When I take 1 minus n is constant, common. When you take 1, it will be 1 minus of this. When you take 0, it is 1. Fine. Now, it does not exist for some n. So it clearly says that this does not exist when n is equal to 1. But we will check about the limit. What will happen as n approaches 1? It's a 0 by 0. So once it's a 0 by 0, we have to take the L'Hopital rule. What is the derivative of a raised to power x? A raised to power x log a. So 2 raised to power 1 minus n log of 2 and derivative of minus 1 as well. This is 0 here. So what is the limit as n approaches 1? It's a 2 raised to power 0 1. It is a ln of 2. That's my finite number. So it means limit lambda of 1 exists. So the first option is cancelled, because it exists for all except the 1, but at the 1 the limit is finite. Then look at the second option. Lambda does and sequence is unbounded. How you can check that sequence is bounded or not? We will check about the limit of this. This is a sequence. If you prove that this is a convergent and every convergent sequence is a bounded sequence, and how you can prove that sequence is convergent? We will take the limits and we prove that it's a finite, then it's a convergent. So this is my here. If you take as n approaches infinity, again you can see it's a infinity by infinity. So L'Hopital rule, you take the derivative, you will get this expression. Now once you take as n approaches infinity, this is my 2 raised to power minus infinity ln of 2 minus 1 over. So what is that? This value. This will goes to the 0, which is a finite number. It means the sequence of ln is my convergent. Once the sequence is convergent, it implies this is my bounded. So once it's a bounded, the third option is correct. Second option is cancel. Okay, now look at this last option. How you can find the limit of the sequence? How you can find the limit of the sequence? We can use the property. We all knows how you can use this. You can simply simplify them as n plus 1 over this. Do you remember which result is here? This is the Cauchy's second theorem on the limit. So what is that? Limit as n approaches infinity. What is the n plus 1? This value is my n plus 1. So it will be my n plus 1. So if you open them, it is my minus of n. 2 raised to power minus n of here over 1 minus n minus 1. 2 raised to power 1 minus of this. So clearly says that when you take is n approaches infinity, this value will be 1 minus n over n. Fine. So what is the value of this? It will goes to the minus of 1. So this part will goes to the minus 1. This value, when you take as n approaches infinity, this value will be the 0. This value will be minus 1. This value will be, sorry, this is a minus also, so it is a plus 1. This is a 0, this is minus 1, 0, minus 1, plus 1. So the right answer is my plus 1 is also the correct option. Okay, look at the last question. Okay, that's a very simple question. You can simply take a function f of xy goes to the 0 when, you can simply remember, when the numerator degree of xy is greater than of the denominator degree xy. That's a simple shortcut tips for you. What is the numerator degree of the x and y? That is alpha plus beta. What is the denominator degree of the x and y? It's a 2. Root of 2 is my 1. So check which one contained here. Look at the first part. S is contained in here. If I take alpha is greater than 0, beta is greater than 0. What is the meaning of that? Alpha plus beta is my greater than 0. So if you take x, this is my, and this condition here, so which already, this value already contained in this case. So it means this is the right answer. Look at the second part. Alpha greater than 2, beta greater than 2. The sum will be greater than of the 2. So if I take, this is my 2 and this is my 1. So we need this one. This number contained here, but we need an opposite of them. So this is a wrong answer. Third is obviously satisfied. Fourth is, if I check whether it's a greater than 1 or not, if I write this number like of this number is my greater than 1 plus of 3 beta. What is the meaning of that? This number is greater than of 1 times of this. So that definitely this is contained in here. So the right answer is A, C and D are my correct answer of this problem. Okay, so I hope you can simply learn these various concepts. You can like, share and comment on my videos. Remember the shortcut tips for solving the problem. Best of luck students. Happy learning.